So you did this one for homework, but I thought I would throw it out here. Two fingers hold 3 blocks. I'm not going to ask you to draw the thing. I'm just going to ask you, what should we use from our 9A toolbox? Kinematics, Newton's second law for translations, Newton's second law for rotations, one or more conservation laws, or more of these. I want a free body diagram for each block.
Are the fingers pointing at the exact center of the blocks?
Sure.
Doesn't it matter?
It matters for the actual drawing, but not for the answer that you give right here.
I think he's saying that if they're off center, then you might have a rotational.
Oh, I see. No, they're pointing at each other. Whether they're down below the center or up above the center, they are exactly pointing at each other. Yeah. Pardon me? Let's put Newton's third law. Let's put these as Newton's laws. I don't know why I didn't do that. Newton's laws for translation, Newton's laws for rotation. So, last chance, get some sort of an answer in.
So we are assuming that the fingers are right at the center, right? Pushing at the center.
Or
I would say they're pointing at each other, and let's not worry too much about whether they're at the center or not, because you can hold things up, perhaps, if they're not at the center. Although, yeah. Question? Yeah, kinematics is just about accelerations and velocities and positions. Not dynamics, not where you have forces and things moving in time. Dynamics involves forces and torques. Newton's second law for translational motion is the main one, and other people put more than one of these. Can I assume if you put more than one of these that Newton's second law for translational motion is one of them? Okay.
Yeah.
What's the other one?
Newton's second law of rotation.
Newton's second law for rotations. Anyone think you need to worry about rotations in this problem?
Yeah.
It's an extended object, so you might have to think about it. Do you have to think about it, I guess, is the question.
Well, because if they're not pointing at the center, and you do it at the top, wouldn't the center block wouldn't they try to rotate as such? Like,
let's say this is rotating. Let's say this is pushing exactly at the center, so I don't have to worry about that. If these are pushing exactly at the center of the block, so these are at the center. What do I know about the forces on this block? I see a downward force right now. And so Newton's second law better tell you something about other forces. There has to be an equal upward force for it not to be accelerating. Upward forces, got to be friction forces. What do you think? Can I put a small can I put all of the friction force on this side?
No. Well,
all of it right there, so that exactly cancels. Because Newton's second law for translations would say I ought to be able to do that. I've canceled the forces, that ought to be fine. That ought to be equilibrium. But it's not. So first of all, I can't have any torque on this thing if it's going to be in static equilibrium, which means I gotta worry about Newton's second law for translations too. Even right now. In fact, the only way I can make sure that there's no net torque is to make those two friction forces equal. If they weren't equal, then there would be a torque on this thing. And so number one is I got to worry about rotations whenever I have forces applied in different locations on an object. I got to at least think about it. And here you have to, even to take the first step, you have to. There's also, what about Newton's third law? If there's a force, this is force by left on middle. By Newton's third law, force by middle on left. By Newton's third law, that's their upward force. There better be friction with the hands. Try to do this with your hands, greased up on frictionless Teflon blocks or whatever, and you'll find that it just slides right out of your hand. So you need a force upward equal to those two. Force upward by your hands. Where did that force upward come from? Well, it's a friction force. So this normal force that I've drawn like that, it's got to be a lot bigger. I didn't leave room to draw it as big as I could, as big as I need. What about other things, like if there's a friction force here, that means there was a normal force by that one. There's a friction force here, there had to be a normal force by that one. So far, that's okay. What if I draw the normal force that way? In other words, there's a normal force pushing on that too. Is this object right here in static equilibrium? The way I've drawn it, I think there's a net torque. And the reason I think there's a net torque about the center of mass is that this force is smaller than that one. I think there's a net clockwise torque. I think if you're holding those like that, and you should try it, that one on the end is trying to rotate out. In fact, since there's a net clockwise torque, you might do well to put your hand down below, down a little lower against this thing, and so produce a counterclockwise torque around that center of mass. And if I'm going to do that, whatever I do on the left one is equally true on the right one. It turns out in order to hold three of them up, three of them is not very hard, but it'll be easier on you. You won't have to push as hard if you have your fingers down below the center of mass of the two. And if you try to do 5, You're going to have your fingers all the way at the bottom, and you're going to be pushing really, really hard so that this counterclockwise torque due to your fingers pushing is big enough to cancel the clockwise torque. So I wish I could pass, I don't know, 500 blocks around for you guys to play with, because you would see that problem shows up. At large enough numbers of blocks, the middle of it just rotates right out, and you lose them. And that's why you can't stack those things up more and more unless you can push harder and harder with your fingers, but eventually you run out of finger pushing also.
Or if you get material that has an incredibly high friction force, like Velcro blocks.
That's cheating.
That's not cheating. That's
If you glue them all together, so the friction force, so the kinetic friction, those the perpendicular forces can be really big, then you'll have an easier time holding them up.
In fact, you might be able to hold it up from one end. Right?
I'm sure you can. Almost any time you draw a large object and there are forces applied in lots of different places, you are going to need to think about translational motions and rotational motions. Almost always. Not always, but almost always.